So how do we actually know that the area of a circle is pi r squared? How can we convince ourselves of this fact? Well, recall that pi, by definition, is the ratio of a circle's circumference to its diameter, or pi equals c over d, or c equals pi d, or c equals 2 pi r. Now, to convince ourselves that the area of a circle is pi r squared, let's throw a circle of radius r up on the screen. What we're going to do is we're going to rearrange the area of the circle into a more familiar shape, that of a rectangle. And we're going to do so by dividing the original circle into n equally sized sectors. Let's say n equals 10 for the purpose of this illustration. So that means we can then rearrange those 10 sectors into this following shape, which is sort of like a parallelogram. So it's like a parallelogram-like shape. And we can convince ourselves that as n goes to infinity, as the number of sectors approaches infinity, the parallelogram-like shape would become more and more like a rectangle. In fact, it would be a rectangle if n could ever reach infinity. And so what that really means is, if we could find the area of this rectangle, then that will be the same as finding the area of the original circle. So let's recall that the area of a rectangle is base times height. What would be the base of this rectangle? Well, after a moment's thought, we should realize that it's just pi r, half the original circle's circumference. It's half because the entire circumference will be divided equally between the top and bottom sides of the rectangle. And it shouldn't be too hard to see that the height of the rectangle would just be the radius of the original circle. So putting all of that together, we get that the area of this rectangle would be base times height, or pi r times r, which of course would get us pi r squared. So that tells us that the area of both this rectangle and the original circle is pi r squared. So in a way, we can kind of think of the rectangle as the limiting shape of the circle as the number of equally sized sectors n approaches infinity. I find that's a pretty neat visual proof of why the area of a circle is pi r squared. I hope y'all enjoyed that. All right, with that, I hope you're doing well. I know I am on this beautiful day in Chicago. All right, make sure to hit that follow button for more math content. And as always, I'll catch you on the next one. Take care.